p23, starting to look at matter and how it's classified. There's two major ways that we can classify matter, one being the phase it exists in around us naturally, or based on its composition and structure. So on this page, we're going to take a look at classifying matter based on its phases. You should be able to compare and contrast the three major states of matter: solid, liquid, and gas. So let's take a look. There are two major factors that impact the phase of a sample as it exists in nature. So the first thing is the particle's average kinetic energy, which we have already talked about this year, and that is just simply referring to the temperatures of the particles. The other factor, which will be a newer idea for us, is the particles, their attraction for each other. So the particles' attraction. And I'm going to put the word strength. So how strongly are they attracted? So attraction, strength. Now, in chemistry, later on in the year, we'll talk more and more about the particles' attractions for each other. It does have a fancy name, intermolecular attractions or intermolecular forces. So I simply will abbreviate it IMA. So their attraction strength for each other. So taking a look at matter at the macroscopic, this would be the first way that you learned how to classify matter as a solid, liquid, or gas. What happens to each phase as you move it from one container to another container? So a solid, when you grab a solid object and you transfer it from one container to the next container, okay, its shape, it does not change. So I'm going to write not change. And when we say that in this aspect that its shape does not change, it means that it has a definite shape. So I'm going to write the word definite. Or we could also use the word fixed. So its shape is definite or fixed. Now, also, when you transfer that solid into a different container, the volume or the amount of space that it occupies, the volume does not change. So a solid also has a definite or fixed volume. Now, the phase that is the most opposite of a solid is a gas, okay? And so a gas, when you transfer it from one container to another container, its shape changes. So that means that its shape is not fixed. It is not definite. And the same thing happens with the volume of the gas. The volume changes based on the container that holds it. So a gas, it will try to fill or occupy the entire container. So I'm going to write here in purple. So gases, they fill the whole container. So that's something that makes a gas unique. Now liquid, it is the phase that is the connector between solid and gas. So that means that the liquid, it needs to have one of these characteristics in common with the solid, but then it has the other characteristic in common with a gas. So if you take a sample of liquid and you transfer it from one container to another container, the liquid will adapt its shape to the liquid. Will adapt its shape to the container. So a liquid, its shape changes. So it is not fixed. But The volume or space that it occupies is the same characteristic as a gas. Just because it takes the shape of the container, it still occupies the same amount of space. So its volume is fixed or definite. Now, the reason that the shape does not change, or it changes based on the container, the volume remains fixed, or it doesn't, we have to look at the particles at the microscopic level. And we have to be able to draw particle diagrams. So if I was to draw a particle diagram of a solid, each circle represents a particle. So I'm going to draw this. So notice how I'm drawing it. And one of the things that you should notice is that when I draw this, that the particles touch each other. I should say touch. And they maintain order. So they're organized, or they are placed in order. Now, a gas being the complete opposite of a solid, its particle diagram should be the opposite. So when I draw a gas, okay, notice that the particles, that they don't touch, so I'm going to write no touch, and there is no order or organization. So there's no touch and there is no order. But when we look at the liquid, because it does have one characteristic in common with a solid, but a different characteristic in common with a gas, its particle diagram needs to represent. So take a look how I might represent a liquid. So when I draw the liquid, the particles touch, but there is no order. And so because how the particles relate to each other within the sample, we can relate this back to their attractions for each other, the IMAs. So IMA, that's the attractions. So solids, because their particles touch and are held within a type of order, or very organized, they have a definite fixed shape and volume. This would indicate that they have very strong attraction. So I'm going to write strongest. Where the gas is the complete opposite, the particles don't touch, there's no order, that their shape and volume changes based on the container we put them in, and that's because they have the absolute weakest IMAs. Some people, they're so weak, some people say they don't even exist. Where liquid, so its IMA strength has to be somewhere between how strong they are in a solid to extremely weak. So because the particles touch, okay, the IMAs are relatively strong. So we will just write strong here. So strongest attractions between the particles making a solid, they're relatively strong in a liquid because the particles need to touch, but they are very, very weak in a gas. So what that leaves us with here is the movement within a sample. So the attractions are so strong between the particles within a solid, the movement is very limited. Whereas a gas, the IMAs are extremely weak, no order, no touching, that they pretty much have complete freedom in their movement. So for a solid, so its movement is limited. So it's probably just limited to the idea that the particles vibrate, or vibrations within their fixed position. Where a gas, they have complete freedom, so their movement is described as being very rapid, and the particles, because they don't have any attraction, they tend to move apart from each other. So the liquid, a couple of words we tend to use when we're transferring a liquid from one container to another. So liquids, we tend to pour them from one container to another, Or out in nature, liquids, we describe them like when they're in a river, is they tend to flow. So there is mobility within the sample, but they stick together. So they have the ability to slide around in the samples. So slide around in the sample. So now underneath this on our notebook page, there are 3 multiple choice questions. Try those and check your answers with the teacher.